Okay, so I think in short, what we are trying to do for today, we try to recap some of the question that we addressed previously, and then we will see how you guys try to answer that particular question according to the groups. Okay, according to the groups. I think in this stage, suggest we'll go to the commenting on your answer regarding the question. Okay, and then yeah, so maybe it's just comment. Okay, that's correct, not correct, or incomplete. You need to go for others statement, which is the keyword for the answer. That kind of approach. Okay, so that you guys can, I mean, can get the better answer if those are not produce the so-called good or precise answer. Okay, that is one point. Secondly, if you manage to complete that session earlier, so we're thinking that, so we give you guys the opportunity to form a group. I mean, according to group assignment. Okay, and then so we'll go maybe very quick for each group if that's any problem or question you want to ask regarding your assignment. And depends if you have the question, then you can answer during that meeting in the group. Meaning to say, after this question, I mean the Q&A question regarding the tutorial parts, we will form in a breakout session, and then you will be enter your group accordingly. Okay. So I think that's very clear. So I think so we'll go for the question that represent the group number 1. So does anyone from group 1 want to respond the question? I mean the question and answer. So try to share the screen just to look at the question so that everybody can refer, or those others group, if you guys want to ask or answer as well, there should be no problem. Okay, but then we go to the focus of the dedicated group, which is we have been assigned for the respective question. So we try to share the WhatsApp list. Okay. Everybody okay sihat semua? So tak apalah, so je yang tak sihat juga sihat, okay lah. You guys can see my screen?
Yes, sir.
All right, thank you. Okay, so that's the question. Okay. So different between OGPV and GCPV, group 1. Any member from group 1 want to respond this question? So while waiting for that, so we try to get the list of the group member. Okay, the list of the group member. Group 1, anyone? Or you guys not remember who is your, what you are going in your group? So let's have a look who is the group member. So here we have okay, Ahmad Hishamsul, Chia Zifong, Muhammad Aizat, Nur Batrisha, and Ahmad Aidil. Anyone want to answer the question? What's the difference between the OGPV and the GCPV?
So,
Who's on the line?
Chia.
Okay, Chia. Okay, Chia. How are you, Chia? Everything okay?
Yeah, okay.
All right, okay. So, Chia, so I think you are representing the group one.
Yeah.
So, can you share to us what's your group answer or maybe your personal answer for that question?
So, difference between OGPV and GCPV is OGPV is off-grid and the GCPV is grid connected.
Okay.
Okay, so for OGPV, the electricity is come from the panel or store and the electricity will store in battery, means no extra electricity from grid. While
Okay.
for grid connected, if system not produce enough electricity, can pull energy and can pull electrical energy from grid.
Okay.
So for OG, it needs more battery to store the electricity, while for GCPV is depend on the grid. If if it's
All right.
not enough electricity, he will pull from grid or pull from the electricity from the store battery lah.
All right. Okay. Okay. All right. Okay. Thank you, Chia, for your answer. So, any member want to add on, or others want to add on, or others want to ask? Of course, not asking again. Of course, right? All right. So, thank you, Chia. But the key point, what we are trying to highlight, what is the different, obvious difference of the OGPV and the GCPV, beside the direct translation of the acronym OGPV and the GCPV of grid photovoltaic and also the grid connected photovoltaic is the system itself. For the OGPV, dealing with the battery as a part of the storage and power system to electrify the PV. Okay? And then for the GCPV, it relates to the grid. I mean, for such as for the Peninsular Malaysia, TNB grid. Okay, and then there is the main core of supplying the electricity to the electrical appliances. Okay, so thank you, Cha. So very appreciate it. So group one can move on. Right. So next we go to the group number two. So we will see who is the group number two.
Saya volunteer, Doktor.
Who's on the line?
Daniel Iskandar, Doktor.
Group two. Okay,
Yes,
okay, Daniel
kan.
Iskandar. Alright, alright. Okay, okay. So Daniel Iskandar. So ini ketua kumpulan ke? Bukan lah.
Tak sure.
Ke terpaksa ke apa ni? Okay, kena game dengan kawan-kawan dia kan? Mana lah tahu kan?
Tak ada, Doktor.
Okay, okay, okay. Tak apalah, kita sama-sama belajar lah kan? So, okay. Nak panggil apa dia? Daniel ke? Iskandar ke?
Daniel.
Daniel lah, right? Daniel Iskandar Izhar. Okay, Daniel lah. Daniel. Right. So Daniel, so can you share to the class what is the difference between the VOC and the VMP. If you guys try to
Okay.
notice, this kind of term should be available in a PV datasheet. So just to get the idea, what is the difference between the VOC, voltage open circuit, and the VMP, voltage mean peak. Okay, so please, Dana.
Okay, Doctor. Okay, from my understanding, so VOC is open circuit voltage, and
Okay.
the VMP is the maximum power voltage. So open circuit voltage occurs whenever there is any load connected to the PV modules
All
and
right.
the current is not flowing. But for maximum power voltage is the amount of voltage produced by the module that correspond to the maximum amount of power for that module.
Okay. Okay.
Because
Good.
PV modules are rated
Good.
to different voltage values.
Alright. So anyone in the group want to add on, or others want to ask, or others want to add on the answer? So welcome for you guys to so-called add on, add on. Okay. Uh, so thank you, Daniel. I think this is a very good answer. I mean, it able to represent the difference between the VOC and VMP respectively. In short, VOC is the voltage, okay. OC refer to the open circuit, meaning to say there's not any connection with the load or with the other things. It's just a matter if we have the PV and the PV have the positive wire and negative wire, and then we just try to connect that both wire to the multimeter. Let's say in this case, you are trying to go for voltage, you set at the multimeter is the voltage, and then you just connect, I mean the positive PV with the positive multimeter and the negative PV with the negative multimeter, and set the range you are looking for, let's say for voltage, for this case it's voltage, and then you get the value. So that's the value of the VOC, meaning to say there's not any related with the load or any connection with the other appliances or the electrical appliances at all, compared to the VMP. So with the same approach, but then the PV have gone through the others connection with the load perhaps, or with the inverter, with the battery, with the others kind of connection, then it will give you the value of the VMP. Is that the same answer with you, Daniel? So we try to respond that.
Uh, yes, Doctor.
Okay,
Cuba
mesti yes
tell
kan?
me a little bit more detail.
Yeah. So because what guys, these two values also should be appear in the data sheet. And these two value, if you notice, when we do the sizing, we need to consider is a part of our consideration to do the calculation, right? Because of course, VOC, we have the value. Okay, we have the value. We need to consider it's a part of the sizing and also the VNP. So it a very open calculation, which one is the better. There's not any such thing about the which one is the better. It's just the matter of is that VOC or VMP have the significant changes with the configuration of the temperature, because we know that when we have go through the main factor of the power of PV, it relates to the irradiance due to the current, and then the temperature due to the voltage. Okay, so that's why the consideration of VOC or VMP need to be taken into account to ensure that we are not wrongly do the sizing for to formulate our configuration of array. I mean for our PV. Okay, guys. All right. So thank you, Dana. So very appreciate it. Okay,
Okay, Doctor.
so we go to the third question. Third question. Okay. All right. So ini very straightforward, ah. Okay.
Sir,
Okay, apa ni? Yeah, who's on the line?
Kwa.
Okay, Kwa. Yes, Kwa.
According our discussion yesterday, we found that from the note, the answer is solar pathfinder, and from the Google, the answer is pyronometers.
The one is what? The one is referring to what, Kwa?
The The Google one.
Of what? Yeah lah, Google one of what? Of what question? Oh, okay. Ni, question number 3.
Yes.
Okay. You go too early, Kwa. So, okay. Alright, so we look at the group member first. Oh, Kwa is a part of the team. Okay. Ahmad Najmi, Kwa, Lokman, Amirul, Nur Syafina. So, Kwa is the ni ke? Ketua ke? Ketua lagi?
Bukan.
Oh, bukan. Okay. Si ketua Kwa je lah. Nanti penat lah Kwa kan? Yeah, right. So, okay. So, based on your answer, Kwa, what is the answer for the
Uh,
3?
according to the notes, the answer we found that the answer is solar pathfinder, and we Google the answer is pyranometers.
Okay. So, which one?
Um,
Okay, meaning to say you try to mention to sir, you have a 2 answer.
yes.
Okay. Okay, open to the others. Open to the others. If team member want to add on or others want to give their opinion or their maybe their point of view, perhaps. Okay. So as usual, so ask, so answer, sir. So scorer there. All right. Okay, so number 3 question. Actually, it sufficient to mention that your second answer, Kwa. Meaning to say you are mentioning regarding the pyranometer. Okay. Sebab during the solar pathfinder, okay, when we are dealing with the solar pathfinder, actually we do not know is that throughout the day we are receive all is direct irradiance or diffuse irradiance solely or global irradiance solely. So it can be mixed, it can be alone, it can be sole of irradiance, which is this is a very uncertain condition when you are answering based on the solar pathfinder. But if you are saying about the parameter is the device to measure the global irradiance, is yes, because that's the dedicated equipment or device that able to measure the global irradiance. Is that okay, Kwa and team?
Yes, doctor.
All right. Okay. So the answer for the global parameter you get from the what? Google.
Yes.
All right. Okay. So at least safe answer lah. All right. Okay. Thank you, Kwa, for
Thank
your
you.
response representing the group 3.
Thank you, sir.
Okay. Welcome. Okay. Okay. Sorry, guys. Alright, so we go for the group number 4. So we try to look who is the team member. Okay, Ezarul Adam, Kogulen, Muhammad Nur Syafiq, Muhammad Ammar, and Nur Hanani. Okay, right. So any representative from group 4?
Hello, Doktor.
Oh, yang ada pun. Siapa ni? Syafiq. Okay, Syafiq Alright, saya nak highlight lah siapa-siapa yang jawab ni. Boleh tak? Kan kita boleh nak tanya yang lain kan? Okay, steady Right. Okay, Syafiq. So back to the question. What is the difference between unglazed and glazed thermal collector? Ni kena panjang sikit ni, Syafiq.
Yang untuk different ni, grup kami dapat 7 perbezaan.
Okay.
Okay. Dari segi fizikal, kita boleh tahu yang glaze ni dia ada gelas. Gelas.
Okay.
Untuk unglazed ni dia tak ada gelas dekat atas dia, permukaan dia. Lepas tu yang kedua perbezaan dia, glaze ni dia boleh store the heat between glass and collector.
Okay,
Untuk
correct.
unglazed dia unable to store the heat.
Alright.
Okay, yang ketiga
In the form of the top surface lah kan?
dekat atas. Untuk yang ketiga, glaze ni dia lost less heat.
Glaze Less heat, okay.
Untuk yang apa ni, unglazed ni dia lost more heat lah. Dia banyak
Due to
apa
what
ni,
heat transfer? What due to the what mode of heat transfer? Convection kan?
convection.
Right, okay.
Okay, yang untuk yang keempat, kalau dari segi thermal efficiency ni, glaze ni dia high thermal efficiency. Untuk unglazed dia low thermal efficiency.
Okay.
Lepas tu yang kelima, untuk electrical efficiency, glaze ni dia low electrical efficiency. Lepas tu yang unglazed tu dia high electrical efficiency.
Okay.
Okay, yang keenam, glaze ni dia mahal sikit lah. Dia more expensive.
Nama apa tadi? Syafiq?
Ha?
Yang keenam.
Yang keenam dia more expensive. Untuk glaze, dia mahal sikit.
Oh, okay, expensive. Okay.
Unglazed dia murah lah. Dia cheap.
Murah. Okay lah, kan tak ada camin kan? Okay.
Okay, yang terakhir yang kami dapat, yang glaze ni dia unnecessary to clean the thermal collector regularly due to the dust and impurities.
Okay, so that one is glaze ke unglazed?
Glaze.
Glaze, okay.
Untuk yang unglazed ni dia necessary to clean the thermal collector regularly to avoid irradiance blockage.
Okay.
Okay, itu saja daripada.
So you have 6 difference for that kind of comparison.
Ada 7.
Oh, 7, sorry. 7 kan? Okay, ada 7. So any comment from the others? I mean from others group member or others student? Ni lock lah ni. Ni lock lah ni jawapan ni. Syabik ke?
Tak pasti ya, takut ada salah lah.
Okay. Anyone want to ask or want to give opinion? Okay, Syafiq and team, I mean group 4 kan? Okay. So more than agree for your answer only on the part of your answer number 5. Can you repeat it again, Syafiq? Answer number 5? Point number 5?
Electrical efficiency tu ke?
Ya, betul.
Glaze tu saya dapat low electrical efficiency. Unglaze dia high electrical efficiency.
Alright. So when we deal for this kind of question, okay, you need to remember for the thermal collector, we only deal for the heat. Okay, thermal collector,
Thermal collector.
So when we talk about the electrical, it always relate to the PV, photovoltaic. So in this case, for number 4, there's not any such thing related to the PV or solar. So there should be no anything related to the electric spark. Kan? Kan.
Yes.
So if you say so, it seems like you are mentioning about the PVT, photovoltaic thermal. It's not the PV alone or not the thermal collector alone. What we are trying to discuss here, question number 4, we go for the dedicated thermal collector, which is no deal at all relates to the PV. So there's no answer related to the electrical efficiency and etc. Agree, Syed? Agree?
Agree.
Hello, Syafiq.
Hello.
Syafiq and friends. Ada? Okay.
Ya.
Okay, kan?
Agree.
Kalau tukar this question, buat macam, what is the difference between the unglazed and glazed for PVT or photovoltaic thermal, then we can consider number 5 is a part of the answer. But if you ask what is the difference between the unglazed and glazed thermal collector, then it should not include point number 5 at all.
Okay.
Alright, sebab we are just dealing with the thermal part, which is producing the heat in the form of the water or air. I mean for the space heating for the hot water. So there's no any related to the electric. Okay, cepat ya.
Okay.
Alright,
Terima
thank
kasih,
you
Doktor.
very much. So,
Okay.
can go for the next following question. Question number 5. What is the difference? Alright, okay, so I think it's a very straightforward question, but yeah, we just go for the representative lah. Who's on the line? I mean, from group 5, Aisyah, Manisa, Muhammad Safwan, Muhammad Ashraf, and Muhammad Afif. Anyone?
Hello, Doktor.
Hello. Who's on the line?
Safwan.
Safwan. Okay. Safwan. Sorry guys. Okay, Safwan. So same question. I mean, same question more or less with the number 2, but this kind of form we going for the ISC and the IMP. Can you share to the class what's the difference between the ISC and the IMP?
Okay, first of all, ISC stand for short circuit current,
Okay.
and IMP stand for current at maximum power.
All right.
Okay, for the ISC, it is obtained when
Safwan,
the
buat sikit Safwan, suara Safwan.
oh, okay, sorry, sir. Hello.
Baru garang sikit. Okay.
All right. For the ISC, it is obtained when the positive and negative terminal of the panel are connected to each other through an emitter in series.
Okay.
And it is represent the highest current that the solar panel cell can deliver without any damage.
All right.
So the function is to determine how many amps a panel can handle when connected to a device. It is also for the ISC need to consider when do sizing. For
Okay.
example, for
Both of it,
parallel
yeah.
string. Yes.
Okay.
And next is for IMP. It is current obtained when the solar panel produce their maximum power. This means this it is amperage when connected to solar equipment. Solar equipment, for example, inverter, battery, and solar controller. I think that's all, sir.
Okay, that's all.
Yes, sir, that's all.
All right. Okay, right. Just to add on the question, because this one is mostly has been covered for the question number 2. Safwan, can you try to relate the ISC and the IMP with the IV curve? I mean the IV curve performance of the PV electricity power output. There's any correlation between the effect of the temperature or effect of the irradiance?
Yes, sir. In the IV curve for ISTC, it is obtained when voltage across the device is 0
Okay.
and at full irradiance. And while for IMP, it is maximum. It is current they obtain from maximum power in the IV curve.
All right. Okay. Okay. Yeah. Okay. Thank you, Safwan. I think maybe during your answer, it should be in your mind. I mean, in your head, should be have that kind of IV curve that show the IMP, right? I mean, because they have the curve, then you need to plot it with the dotted line, and then you have the square box. That point of the IMP is that the representing the square box lah for the power output for the IV curve. Is that correct, Safwan?
Yes, sir.
Kan, so samalah kita punya imaginary ni. Right. Okay, good. Thank you. Okay, thank you, Safwan, for
Okay, thank you,
your
sir.
answer representing group 5. So we go to the next following group. Group 6. So we try to look at who is the representative for the group 6. Oh, group 6 ada 4 member je. Akmal, Irfan, Fina Sofia, Tegeswari, and Muhammad Azrul. Okay. So who's on the line?
Azri.
Azri. Okay, Azri. Azri ketua ke Azri?
Ha?
Ketua ke? Ketua grup kan?
Tak.
Tak. Okay, dia bagus semua macam humble je Bagus. Bagus semua tak nak jadi
Kata kalau
pemimpin
saya jawapan dekat WhatsApp, Dr. boleh tolong sharekan tak?
Macam mana? Ni.
Tak boleh.
Apa dia? Apa tadi? Tak dengar.
Saya share
Oh,
jawapan
kamu
dekat
nak
WhatsApp.
share? Nak share ni dekat screen.
Jawapan je.
Okay, boleh. Stop sharing
Nanti saya
seminit.
baca.
Jadi kamu share kamu punya answer. Boleh?
Tak. Apa doktor tolong share kat WhatsApp je.
Oh, ada WhatsApp kan? Ingat ke kamu nak share? Mana? Oh, dia kan ada apa ni? Boleh.
Sekejap.
Oh, kamu dah WhatsApp saya belum? Belum.
Dah kat grup WhatsApp.
Oh, kat grup. Okay. Okay.
So FIT stand for feed in tariff and NEM stand for net energy metering. So basically the main difference for these two things is FIT is a mechanism for granted selected customers to export all solar energy produced to TMP grid. And NEM is a mechanism to use solar energy that you produce for your own consumption. So NEM ni ada dia punya advantage dia di mana dia boleh generate own energy and use it to reduce electricity bill. And secondly, can sell the excess energy to TMB and be used to offset it with electricity. That's all.
Alright. Okay, thank you. Does anyone want to add on or ask? Okay. In short, the obvious difference between the FIT and also the FIT, feed in tariff, and also the NEM. Okay, FIT, feed in tariff, NEM, net energy metering. The FIT, the scheme of the FIT, we can sell our extra solar energy produced by our PV to the energy provider for the peninsula in case TNB. Meaning to say, FIT, we can gain back the money by selling our PV power, electricity PV power. But for the NEM, net energy metering, we do not able to get the money back, but we can try to contradict with the assessing power and accumulated to the next following months or until up to the 2 years before it will be eliminated for the extra usage. Okay, so that's the two different things I would say. Regarding the FIT and the NEM, because what? That's why after some of the brilliant people manipulate this FIT system, which they are producing or they buy or they install the huge area or volume of the PV, and suddenly they sell to the TLB and gain in return in the form of the money. That's why they try to introduce the NEM. Okay, meaning to say there's no longer to get the money back while you are producing the accessing of energy by selling to the TNB, but then you can have that extra power from your PV and can be stored or can be reserved as your part of your utilization up to the 2 years before it will be end and start with the zero again. Is that clear, guys? That's why this FIT. We start at first. We start with FIT, but then afterward, we stop this FIT program and the government go for the NEM. Okay, net energy metering. Okay, seems like they are trying to offset, okay, offset. Let's say let's say your PV system at your house producing, let's say 10 kilowatt, for example. Okay, and then at your house you only use 3 kilowatt, for example. So on the FIT system, that 7 kilowatt extra you can convert in the form of the money by selling to the TNB during the FIT system. But for the NEM, that 7 kilowatt you cannot trade in a form of the money, but then you can keep it is the usage for the next following months until 2 years before we'll end to the reset of zero again. Is that clear, guys?
Clear.
Ya, doktor.
Right? Okay, so that's the obvious difference lah, kan. The rest tu in terms of the system kan, of course lah, the FIT have their own metering system, and of course the NEM also have their own metering system. But the concept that's trying to mention is all, that's the thing that went to highlight just now. All right, so thank you, Azri. And then okay, so next we go for the group 7. Okay, so we try to look at who is the group 7. Alia, Haziq, Aida, Faiz, and Sam. So who's on the line? Any representative from group 7?
Saya. Saya, Doktor. Doktor dengar?
Okay, Alia. Alright. Dengar, dengar. Tapi kuat sikit. Ya. Ini macam kalau undi je, sangat slow macam ni je. Kuat sikit. Alright.
Nak kuat.
Okay, Alia. Okay, so
Okay.
the question. What is the difference between STC and the NOCT? Okay, Alia.
Okay, untuk definition STC, dia singkatan untuk Standard Test Condition. It is a industry standard condition under all solar PV panel that test to determine their rated power and other characteristic. And dia punya function used to compare panel, but it does have a limit. Lepas tu dia dalam STC dia tak ada cakap about the quality of panel. Lepas tu STC ni used in standard calculation for string length and equipment sizing. For NOCT pula, dia singkatan for nominal operating cell temperature. It is defined as the temperature reached by a solar panel under a set of conditions that are more in line with real condition than STC. NOCT ni function dia untuk comparing two panel with same STC rating. Lepas tu higher value of NOCT will give the higher performance panel. Lepas tu NOCT ni dia tak digunakan untuk design PV system. Tu je.
All right, thank you, Alia. Before we go the final answer, can you try to define what is the criteria of the STC and the NOCT, Alia? I mean, for the STC, for example, they will deal with the 1000 watt per meter square, T,
macam
temperature, 35
condition
degrees C, and the details.
condition macam tu yang sir.
For the condition for STC and also the NOCT.
For STC, the cell temperature is about 25 degree and irradiance 1000 watt per meter square.
Okay, dia punya AM tu?
AN apa?
AMS.
MS dia 1.5.
Okay, alright. So the what is the STC? So dia punya yang NOCT?
For NOCT, air temperature 20 degree.
Ambient kan?
Irradiance.
Ambient temperature kan?
Uh,
Ke
ah,
cell temperature?
apa?
Yang NOCT,
Air temperature.
ambient temperature.
Ah, ah, ah.
Okay. Berapa temperature ambient?
20 degree.
Okay. Lagi rendah ya. Okay.
For irradiance, 800 watt per meter square.
Okay.
For MS 1.5.
Okay.
Also.
Alright. So if you say just now, Alia, that
Huh?
STC, we go for the sizing.
Hmm.
Okay. So how about the NOCT? When we use this NOCT, wait, yeah, asal je lah. So when we need to consider the NOCT data or application of the NOCT, since it also mention some of the data sheet, kan? So ada answer for that tak?
NOCT.
Ya,
Uh,
macam yang kita belajar itu, we use the STC, is a part of the data we consider for our sizing, kan? So, but as mentioned, some of the data sheet may include the data of the NOCT as well. So, in your group opinion or discussion, so what is the purpose or what is the application, what is the intention of having the NOCT is a part of the data sheet? So, for what the NOCT? Dia tak ada bagi saja kan? Sepatutnya kalau dia tak ada apa-apa, bagi STC je lah.
Is it for compare different solar panel under temperature condition other than STC?
Itu jawapan kan? Okay. Mungkin jangan tanya. Okay. Itulah open to the others lah. Those others group member, if you want to add on, or others team want to add on as well, so should be no problem. But then the more important that you need to understand or need to firm is that we deal with the STC for the sizing lah, kan? Regards to the NOCT. I think so we'll hold this answer for this number 7. Maybe Alia and group try to investigate later what is the purpose of having the NOCT in the data sheet. Is that okay, Alia?
Yes, sir.
Kan, boleh kan? Nanti kita dah lalas nanti kita patah balik nanti mana dah tahu kan kalau dah ada jawapan kan apa.
Okay.
Right. Okay, thank you. So next we go to the group number 8. Siapa group number 8? Tengok. Dia Azira. Okay, ini number 7. Number 8 we have Amanda Maisara. We have Kamal Idham. Kita ada Muhammad Saidan, kita ada Muhammad Izzat and Shalini. Sedap nama Shalini. Alright. So anyone representative group 8?
Yes, sir.
Siapa ni?
Amanda.
Okay, Amanda. Right. Senyap saya highlight dulu ni. Ni Amanda ketua ke? Bukan?
Bukan.
Semua tak mengaku, bagus. Semua tak nak jadi pemimpin. Bagus. Alright. So, mana ni? Give the type of concentrator. I think this question is a very big question actually. But then try to simplify it. At least we can get the idea, the types of the concentrator. If you able to mention it specifically, then that should be great. Okay, Shalini. Amanda. Okay, Amanda.
So, based on my personal understanding,
Your personal, not the group understanding.
Based on my understanding, concentrator ni dia nak fokuskan sunlight. Jadi bentuk dia mesti parabolic. Contohnya parabolic trough, ada parabolic dish reflector. Lepas tu kalau concentrator lain Fresnel dengan heliostat.
Okay.
Jadi bila dia nak collect matahari maksimum tu, dia kena ikut matahari lah. Dia ada solar tracker. Itu saja.
Okay, so I think the answer for this part, Amanda, first thing first, you need to address what is the type of the concentrator at first, kan? For example, we have the Fresnel lens, we have the parabolics, kan? And then, of course lah, the parabolic tu pun ada a few type of style, kan? Ada yang parabolic yang concentrator, kan? Dan sebagainya lah. Ada yang level tower, kan? Tower concentrator. So I think at first you need to describe that type at first, kan? Tak kisahlah refer to the notes ataupun Google ke, kan, ataupun whichever reference book, and then afterward baru you get I'm gonna try to detail, kan, Fresnel ni how it look like, so what is the advantage or disadvantage, in short lah, kan, briefly lah, briefly, so that nanti we can try to have the clear idea the type of the concentrator and the advantage or disadvantage for each. Boleh ya, Amanda? Sebab dia
Boleh je.
personal kan, so mungkin kalau dapat yang punya mungkin lebih meriah kot dia punya jawapan dia.
Okay, thank you.
Okay, welcome. Okay, thank you, Amanda, for the response. Anyone, any group member nak tambah, nak add on some of the question, I mean the answer from your friends? Siapa lagi ni? Amanda buat volunteer ni, dia kena paksa dengan kawan kan?
Volunteer.
Okay, cover. Alright. So guys, so itulah, so macam yang ni yang saya minta ada apa yang kena check balik ni, nombor 7 tadi, nombor 7 tadi nak tengok balik yang NOCT tadi tu, nak tengok balik yang inilah, yang group of the concentrator, kan, right? Tu se-remarks tu lah, sehijau lah tu, ada hutang, right? Okay, thank you, Amanda, for your sharing. So next we go to the question number 9. Give the type of the solar tracker, group 9. So who is the group 9? Oh, power ni. Amir Faris, Jericho, Mugilan, Muhammad Nasrullah, Nurul Hazirah. Okay. Siapa host on the line? Anyone representing the group 9? Kau Gulen? Yes, no? Amir Faris? Berebut bagus ya grup ni. Berebut lagi. Hello? Anyone from group 9?
Yes, sir.
Who's online?
Nurul Hazira.
Sudah agak dah dalam serunya tu mesti ni kamu yang jawab ni. Betul lah serunya. Insting. Alright, so back to the question, kita sama-sama. Give the type of the solar tracker. Okay, so okay. Zira?
So for solar tracker, has two type of solar tracker, which is single axis and dual axis.
Okay.
For single axis, usually move from east to west and follow the sun direction. And single axis tracker only have one angle to use as the axis of rotation. For single axis solar tracker, it has horizontal single axis of solar tracker and tail single axis of solar tracker. Sir, do we need provide the advantage and disadvantage of?
So more than happy if you're able to mention
Oh,
it.
okay. So for single axis, the advantages is more reliable, has longer lifespan than dual axis tracker, and single axis also cheaper than the dual axis tracker because they have simple mechanism and operate at low cost.
Okay.
For these advantages, the energy output is lower by single axis tracker during the sunny condition compared to dual axis tracker because of it only have one angle that is used for the axis of the rotation, so it cannot move um at different angle.
Okay.
For dual axis, it has two rotation of axis degree, which called as a primary axis and the secondary axis. And the rotational, this dual axis also can move downward and upward to adjust the angle of the sun throughout the day.
Okay.
And dual axis tracking allows more accurate orientation of the solar device and provide 40% more output throughout the energy absorption. But the disadvantages for this dual axis solar tracker is more complex and expensive. For dual axis advantages, it follows sun continually and provide a constant power output. It provide a reasonable solution in case of limited power of the connection to the grid, and it can generate 45 to 50% of higher power output per year. And for disadvantages of dual axis is it has short lifespan and lesser reliability, and it also low performance in cloudy and overcast weather.
All right.
And
Oh,
that's all for me, sir.
okay.
Thank you.
Thank you, Nazira. Well explained. In terms of the difference between the solar tracker in the form of the function and also the advantage and disadvantages. Okay, just go back in your group later, Norazra, try to check what is the now roughly the price for the single and the double axis for the solar tracker because this claim for the last 10 years punya comparison. So now maybe technically the double tracker tu, the double axis tu may cost the higher compared to the single, but then we just want to get the idea what actually the range of the price for this dedicated both solar tracker so that we can imagine, oh okay, now we have the one PV, and then if we go for the one solar tracker, for example for the one axis, we need to add on another what ringgit macam tu, Razira, boleh tak nanti in a group cuba try to get a rough pricing for the single solar tracker and also the double axis solar tracker so that you guys have the very clear view what is the current price which is need to be embed or consider is a part of your system because what by having the Nura Azira mentioned just now, it able to increase up to the 40% of the power output. In capturing the solar itself and also to increase the power output, which is tremendously huge. So is that worth? Uh, I mean, as a personal user, to invest for this kind of tracker, either single tracker, single axis, or the dual axis, as a part of our system. Boleh, Yazira?
Okay, sir.
Kan nanti kita tahulah kan maksudnya
So
worth ke tidak kan.
nak cari comparison antara harga single
Harga
axis
je,
double axis,
compare harga.
compare
Maksudnya
dia punya
now single axis harga berapa? Kalau
um,
yang dual axis berapa harga? And then kita tengoklah is that macam work tak kalau kita nak install solar dan kita as a user to consider the tracker is a part of our system as well. Sebab yalah kalau benda tu macam throughout this year semakin murah ataupun semakin affordable, so mungkin kita kena consider lah kan, sebab kita nak gain as huge as much in term of the irradiance throughout the system, because it will may affect the output for our PV system kan.
Okay, sir.
Zira?
Okay, sir.
Alright, thank you Zira for your sharing, to the group member as well. So next, okay, that's good. Okay, next group number 10. 10. Kita ada Anas Farhan, kita ada Jeremy Raj, kita ada Muhammad Fahmi, kita ada Muhammad Syahrul, kita ada Nur Radia. So, anyone from group 10? Ini volunteer, tak tahu lah voluntary ke tidak ya.
Saya dengar tak? Hello? Saya dengar tak?
Dengar. Jangan.
Alright.
ISIS. Okay, so share balik the question. Who's on the line ni? Siapa ni?
Saya Radia.
Oh, okay Radia. Okay. Jumpa
Alright.
Radia. Okay, so question I think is very straightforward. What is the function of the charge controller for OGPV?
Alright. As we learned before, OGPV is off-grid photovoltaic, or we can call it stand-alone solar PV system. So during daytime, the PV will receive sunlight directly, and then in order to control the absorption of the solar energy, so the battery will not be overcharged, we need to install charge controller. So this charge controller will control the amperage and voltage given to the loads. So excess power or converted from the sunlight will be transferred to battery system. Then the battery power is utilized at night when there is no sunlight. That's it.
So just to get the things clearer, what is the smart things that charge controller do for the OGPV?
I think it can control the system, so it managed to balance the sunlight irradiance, and then so it will not cause the damage to the PV voltage, PV photovoltaic.
Okay, alright. Okay, thank you, Nurada. So any members want to add on, or others want to ask or give your point of view regarding the charge controller for the OGPV? Okay, before we go further, I think so we try to explain a bit how the OGPV works relates to the charge controller. Knowing that the OGPV should be paired with the battery, and of course to instruct or to order the configuration of the battery, so we have this kind of device which is the charge controller. Basically when we deal with the OGPV system, so the electrical appliances will be consistently powered by the battery from our battery storage, okay, and the pump in of the AH, from the electricity, will be done during the sunny day or during the daytime, kan? So the presence of the charge controller able to instruct the battery to supply the current to the appliances, electrical appliances, during the daytime or during the night time. But as a part of the function as well, it able to gain the electricity or the sunlight to be stored from the PV to the battery during the sunny day. Okay, in other way around, what's trying to mention, some of the electrical appliances, 100% will be governed or will be supplied from the battery. Okay, and then the top up of the battery will be configured during the daytime by the charge controller to add on the usage of the battery during the daytime or the nighttime. Okay, so that's the function of the charge controller, which is to balance the system so that the battery maybe have a more reliable or longer lifetime, because let's say during that time the sunny is very high or radius is very high, it able to produce the power from the PV, and at the same time maybe we still have the full capacity of the battery, so that the charge controller will control this kind of things to make sure that there's no any excess excess of the power, or not until the drain of the battery before it can be top up from the electricity from the sunny day, during the sunny day. Okay, so that's the thing. Is that okay, Radia?
Jelas, sir.
Okay, it's in line with your understanding, or there's some way around contradiction with your understanding based on your reading previously?
Your explanation is much more better from mine, and I got it.
Okay.
Understand.
Okay. Because what? So when you try to get the idea, that's why, guys, some of the OGPV system, they may introduce this kind of system, I mean, the battery, because we can supply consistent power, kan? Because the battery, yes, just a battery, then they try to supply the things, but the top up for the battery is the PV or the solar system. Okay, so that we can manage to have the consistent power. If not, let's say we reliable on the system which start with the PV alone, I mean PV alone, and then the battery is the second part of the amendment of the power. So we have the problem to get or to obtain the uneven or the fluctuation of the power, right? Because the irradiance is fluctuate from time to time, so we do not get the consistent power, so that it might be harmful our electrical appliances. So that's why we start with the battery to supply the consistent power to our electrical appliances, and at the same time during the daytime, so we harvest the electricity from the PV to top up our battery for the usage during the night time. Okay, guys? Is that clear? Okay. Right. Okay. Any question? Oh, okay. Alamak, Radia dah tunjuk good tu. Okay, okay lah. Okay, dah. Kena macam nak cepat-cepat habis ni. Okay, tak apa. Alright. Thank you, Naradia, and group 10. So, group 10 kan? Okay. 10. So, we go for the next following group. Group 11. So, ah, Ahmad Hanis, Anisha Hima, Muhammad Harith, Nias Aiman, and William Tan. So the question for 11, describe solar chart in solar pathfinder. Right. Anyone from group 11 want to share their answer?
Yes.
Who's on the line?
Buhari.
Okay. Oh, panggil Buhari ya? Ketua ke Buhari?
Ada.
Oh, okay. Semua ni bagus
Ketua.
Oh, ketua. Oh, dah ketua lah. Okay. Dah up lah ni. Okay.
Kalau saya nak share apa? Yang slide yang apa? Yang apa solar pathfinder ni boleh share?
Boleh. Kamu nak share apa? Kamu yang nak share?
Saya share.
Okay, boleh. So stop sharing Sir punya. Kamu masuk share. So stop sharing Sir. So we have 67 participants. Actually, we still miss another berapa 5 or 6 students. 5, 6, 7. Excluding sir kan. Ni participant ni including sir. So another 6 student. Right, so let's go.
Okay, ni solar pathfinder ni dia ada beberapa bahagian yang penting lah. Pertama, bahagian atas ni dia adalah angle to adjust for magnetic declination of the attached kompas. Maknanya dia akan digunakan untuk alignkan dengan kompas yang untuk dalam casing yang solar pathfinder ni lah.
Okay.
Second, ini untuk specific graphically latitude solar pathfinder. Maknanya macam dalam solar chart ni, solar pathfinder ni sesuai untuk 0 hingga 4 north latitude. Maknanya dalam Malaysia lah, untuk Malaysia punya solar pathfinder ni.
Okay.
Yang tengah ni untuk beberapa level to adjust the center level for accurate tracing. Dia benda ni dia akan place dalam dia punya solar pathfinder tu untuk tracing bagi dia balance lah.
Okay.
Horizontal line ni dia indicates demand, and vertical lines ni dia indicate unshaded percentage of sunlight irradiance needed to be added to obtain the percentage of sunlight on the particular month. Sebenarnya dia ni dia akan dikira berdasarkan kawasan mana yang tak dilindung oleh bayang-bayang. Jadinya kita boleh tambah kira berdasarkan kita tambah nombor yang berada di dalam chart ini, dan kita akan dapatlah berapa percentage dia. Saya rasa itu saja untuk solar chart ni.
Alright. Thank you, Bukhari. So I think you may remain this sharing solar pathfinder. So open to the others if you want to ask the question, if any, or you want to add on any information or the remarks regarding the solar pathfinder.
Rasanya tak ada.
No?
Tak ada rasanya.
Okay, Bukhari, can you share to the class, actually, in short, in briefly, how to use this solar pathfinder in very basic way lah, in a very basic way. Let's say we perform the assessment, let's say at the outside of the qubit, kan, in ICRO, for example, and then we have the, let's say, the shading partially, okay, for each month, and then the unshaded and shaded area. So basically, what this solar pathfinder offer to the user by having or using this kind of method to assess the area that you try to want to install the PV system or solar system.
Jadi saya nak describe ke ni? Nak describe macam mana saya guna?
Describe how to use it. I mean, after you conduct the assessment for that particular places, so what's next? What's next? Let's say in your case, let's say you already have half of it, um, katalah shaded, kan? So another half is not shaded, for example. So what's next?
Maknanya ada part yang, kalau part yang tak shaded tu, kita akan kira percentage berdasarkan number yang berada di dalam berada di kawasan unshaded punya dalam solar chart ini.
Okay.
Kira jadi yang kita lepas kita kira ni, kita akan dapat tahulah berapa persen irradiance pada kawasan yang kita lakukan test lah untuk untuk kita letakkan solar PV tu.
Alright. So thank you. So would expect that. So thank you very much, Barry. So and also the group member. Okay. Thank you very much. Anyone want to ask or anyone want to add on before we go for the next following question?
Sir.
Yes, who's on the line?
Emmanuel.
Emmanuel Pang.
Yes.
Yeah.
I want to ask, what's the difference between solar tracker and solar pathfinder, sir? Is there any different or is the same?
There's a very huge difference between solar pathfinder and the solar tracker. Solar tracker is the device that you install on the roof or on the ground, embedded or with the SIM of the PV or solar system, which is able to track. The track is not solely tracked by its own. It track means that it move the PV or solar system as well. Okay. So that's the first thing about the solar tracker. It's just the meter it able to move in the way of the one single axis, one axis or two axis or dual axis. Okay, so horizontal and vertical. So that's the tracker. I mean, device that we consider is a part of the embedded with the system solar. For the solar pathfinder, we do not yet install the solar tracker. For this solar pathfinder, the first step we want to assess that particular area, how much the available sunray that available when we try to install on that particular area, so that we know the blockage surrounding the solar system, perhaps, so that we can do the proper or better sizing when we try or plan to install the system. So I think that's the two different. I mean, there's of course there's a two obvious difference between that parts. But bear in your mind, the solar tracker is the device that functioning with the solar system to capture the irradiance simultaneously or instantaneously during the daytime, compared to the solar pathfinder, which is the pre-assessment before you do the installation of the solar system to check the availability of the sun ray available on that particular area or location. Okay.
Oh, okay. Thank you, doctor. Thank you, doctor.
The two different things. There's two different things. But then it's good to ask because that maybe this kind of exercise we can try to put it first so that we know the availability of the sun ray during that particular area. Then we get the data to consider is a part of our sizing approach. Kan? Because of course when we have the unshaded and shaded area, we will give us the different value of the irradiance. When we have the different irradiance means that we have the different power output. So maybe instead of we need only 5 PV to power our system, so by having the shaded around our installation, we need to add on another 5 to become 10 PV. So that's the crucial of having the assessment pre-audit installation, so that you can get the idea, the cost as well, the budgeting, the sizing to get the so-called proper input in the form of the fact and figure instead of we just in apa what we call that just the feeling or the assumption without any data or any configuration that we can stand for. Okay, am I not?
Oh, okay, okay. Oh, and then one more. Solar Pathfinder is for certain region they have their own Solar Pathfinder, right?
Correct. Based on the diagram just now, if you notice that the highlighted red in color, so for Malaysia, yeah, in the range of the 0 until 4 degree north is good. So for the other country, let's say they are go for the below the 0 higher than 4 degree north, they have their own dedicated graphic of solar provider. They still in the form of the seems like the Batman, the Batman style, but the if you can try to jot down here, so we try. Okay, so the change maybe this kind of thing. This kind maybe for the country that higher this one or lower this one, they have for the upward here, for example. Their grid of the area, or maybe here. It depends on the latitude. So for Malaysia, I mean, in the range of the 0 until 4 degree north, so we have this kind of this shape, this shape. Okay. So if you go to assess the available sun ray at Australia, you may have another type of solar panel. The shape should be the same. This is like the Batman logo, but then the inside here, the grid should be different. It can be either offset or towards the upward or towards the end, or maybe the wider or shorter. It depends on the location. Okay, Nana?
Okay, doctor. Thank you.
Thank you. Bye. Okay, thank you. Anyone? Any question before we go for the next following question? Okay, so if no, so thank you, Bukhari. Bukhari tadi dah.
Nama saya stop sharing.
Okay, boleh stop sharing dah. Alright. Okay, so share semula. Ada so we go for the question, I mean a group graph. Okay. It's quite technical question. I think you guys managed to answer it. Okay, so we have Aris Orhan, Danish Fikri, Fezri Amri, Nava Niden, and Mongkaho. So anyone representative from group graph?
Wakil group 12.
Aris Farhan.
Saya.
Ketua ke?
Tak. Wakil.
Semua bagus semua tak mengaku ke macam tak nak show off kan? Okay, so okay, Aris Farhan, can you share to the class what is your answer representing the question number 12?
So untuk nombor 12 ni dia ada which is Hotel William Bliss. Dan jawapan yang kita orang jumpa panjang, saya pun tak faham. Tapi saya ringkaskan lah apa yang paling mudah untuk ni. So,
kuat sikit tak dengar, tak jelas.
HWB equation ni is a reduced form of an instantaneous thermal efficiency of conventional flat plate collector, yang mana dia mempengaruhi heat removal factor, effective transmittance, absorptance, product, and overall heat loss coefficient. So in a simple way, it is a mathematical model to measure the instantaneous efficiency of the flat plate collector in a computational efficient manner
kata mudah dia untuk obtain collector energy gain. So untuk menjawab soalan nombor 12 ni, dia punya kaitan dalam dia supposedly ada graph, and graph dia tu dia collector efficiency N is plotted against equation Ti minus Ta over L, and then the slope of the line FRUL represents the rate of cross from the collector. Itu je jawapan yang kita dapat.
Okay. Yep. So anyone, I mean, in the group want to add on, or others want to ask, give your point of view regarding the linear slope of Hotel-Wheeler equation, or in short WHE, Hotel-Wheeler Hotel equation, can be by Versal in representing the form of the flat plate collector. Okay. So by right, the linear slope, it should be in a form of the negative slope lah kan? Sebab based on the Hotel-Wheeler equation, dia linear tapi dia negative slope. So that slope representing the coefficient heat losses for your flat plate collector. Okay, so it depends the how serious the slope look like. It can be towards the vertical or it can be towards the horizontal. Okay, but then it represent the coefficient or overall coefficient heat losses for the flat plate collector. If it goes towards the vertical line, so it may go for the higher overall coefficient heat losses. And if they go for towards the horizontal plane, which is that more slanting towards the horizontal parts, so it refer or it represent the low overall coefficient heat losses for your dedicated flat plate collector. In short, so we try to conclude your answer, Arif Farhan, and your group in a way of that kind of description. Is that okay, Arif?
Okay, Doctor.
Okay, same. Tak same.
Yes.
Okay lah, Pak Sim pun kena jadikan same lah.
Okay, Doctor.
Alright, thank you, Arif Farhan. So next, we go for the group 13. So group 13, we have Asaf Ansuri, Muhammad Aidil, Muhammad, ada dua Aidil, Adri, Nur Aina Najwa, dan Yi Jin. Okay, so anyone from group 13 want to answer the question?
Saya
Group 13?
dengar tak, Doktor?
Who's on the line?
Aidil.
Okay, ni Aidil yang Aidil yang ni.
Yes.
Remy
Betul. Ya, betul.
So, okay, Aidil, can you share to the class the question number 13?
Right. Saya straightforward. Untuk soalan ni, soalan minta apakah faktor utama untuk meningkatkan kadar pengeringan. Untuk soalan ni, dia berkait juga dengan apa yang kita belajar dalam heat exchanger, application macam air dryer. So, jawapan ni penting lah. Faktor-faktor ni penting. Alright. Untuk tiga faktor yang utama. Yang pertama ialah temperature, iaitu suhu. Sebab untuk meningkatkan kadar pengeringan, kita perlu tingkatkan suhu. Apabila suhu meningkat, meningkatlah juga kadar pengeringan. Yang itu yang pertama. Yang kedua, untuk
meningkatkan kadar pengeringan, kita perlu tingkatkan air velocity. Maksudnya kita perlukan udara yang maksudnya jika keadaan tu udara ada udara yang apa ni, air velocity-nya speed, maksudnya kelajuan udara dekat situ tinggi, maka bertambahlah kecepatan ataupun tingkat kadar pengeringan. Yang itu yang kedua. Yang ketiga, untuk meningkatkan kadar pengeringan, perlu tingkatkan juga untuk kita perlu kurangkan moisture di tempat tu. Maksudnya kelembapan kelembapan di sebuah kawasan tu perlu dikurangkan lah. Untuk tingkatkan kadar pengeringan. Yang tu.
Okay, good.
Saya ulang balik untuk kesimpulan. 3 faktor utama. Yang pertama ialah tingkatkan suhu iaitu temperature. Yang kedua, tingkatkan air velocity. Yang ketiga, kurangkan moisture. Yang itulah.
Alright.
Mungkin kalau ada sahabat-sahabat nak tambah
Okay.
ataupun nak
Sahabat-sahabat nak
perbetulkan
tambah
boleh.
kan.
Ya.
Sahabat nak tambah, musuh-musuh nak tambah.
Itu saja kata.
Alright, so thank you Adil for very good explanation. In short, what we are trying to deal with is that kalau kita niat nak keringkan sesuatu, mengikut kawan kita punya explanation, idea, dia suggest high temperature and then high velocity. Okay? So to combine this one, seolah-olah macam kita perlukan suhu yang tinggi untuk aliran yang laju. Kan? Maksudnya kalau kita ada macam kita punya, kamu punya hair dryer tu lah kan, nak keringkan rambut tu kan. Kalau temperature dia panas, tinggi, dan dia pun dia punya fan blow dia pun laju, so cepat lah kan. Dan rambut kamu pun tak adalah lembap sangat kan, macam sikit-sikit je, bukannya lepas mandi tu terus kamu hair dryer. So nanti dia incorporate lah to get the better drying rate. It's just the matter untuk rambut tu tak sama lah untuk pengeringan agriculture or marine product kan. So maksudnya depends lah. Tapi maksudnya what I did try to mention, the higher the temperature simultaneously with the high velocity, and of course with the product moisture content is low, it able to give the higher drying rate. Betul kan dia?
Betul tak?
Dah celebrate lah. Okay. Okay, next. Thank you, group 13. So next we go for the group 14. Okay, group 14. So we try to look group 14. Chow Jingbin, Lukman Adam, Muhammad Aiman, Nur Aina, Amalia, Zafira Rusidiana Hanis. So can you know who is the representative for group 14? Any representative?
Good morning, sir.
Yes, who's on the line?
Chow is on the line.
Okay, Chow. Okay. So we try to pick this one first. Chow, ketua kumpulan ke?
No.
Ada disuruh semua tanya, semua bukan ketua kumpulan. Susah jadi pegang amanah susah jadi pemimpin Kemudian group assignment pula tu. Okay, Chow, back to the business. What is the value of peak sun hour for Malaysia? In the range, I would say range, ranging.
Malaysia has an average peak sun hour value of 4 to 5 hours, usually from 11 a.m. to 3 p.m. And then for the average solar irradiance that we receive is around 4.21 to 5.56 kilowatt hour per meter square.
Day?
Yeah, per day.
Okay. So
that's all for this question.
The good things are so very clear to understand your answer. I'm hoping the rest will be the same. Okay, okay, guys. Anyone when you ask Shah or others member in that group, maybe you can ask what is the meaning of the peak sun hour specifically? Can is that different between the irradiance or radiation, which is in a group 15 question? Okay. Okay, Cha, in short, if somebody asks to us what is the measure peak sun hour or PSH in short, so what is the exactly the answer should will be shared to the those who are asked the question.
So the meaning of peak sun hour or the
Yeah, the
amount
meaning
of
of the
sun
peak sun
hour
hour,
or the
and then
meaning?
let's say that, oh, okay, after I get your definition of the peak sun hour, so actually, what is the peak sun hour formulation? So what you should give the answer. You may
So
go or you
peak
may
sun
start with
hour.
the what is the definition of the peak sun hour at first, Chow. Later, then you go for the question. What is the value of the peak sun hour formulation?
Okay, so the definition for peak sun hour is in 1 hour, the intensity of solar irradiance reaches an average of 1000 watt per square meter.
Okay.
So that's the definition for peak sun hour. And then
So,
for
back to the question. So, what is the value of the peak sun hour formulation?
Malaysia is around 4 hours, 4 to 5 hours. And then usually it starts from 11 a.m. until 3 p.m.
Okay, all right. So thank you, Chow, for that answer. I think the keyword to answer this question is that we are mentioning that um, during the 1000 watt per meter square, okay, during that 1000 watt per meter square for Malaysia specifically, we able to reach 4 hours or 4 until 5 hours flat. So that's the question. I mean, this kind of question represent that kind of um, this kind of question represent that kind of approach to understand. Because what actually the peak sun hour refer to that uh, for the 1000 watt meter square from let's say um, 8 a.m. until 6 p.m. Okay, so actually Malaysia able to reach that how many hours? Macam itulah in other way around of this question. So yes, that's correct. Our friend's answer. 4 to 5. But then we go for the 4.5 Chow, 4.5, 4.5. The peak sun hour formulation. Okay, so this one is very crucial because they represent the availability of um, the irradiance throughout a day. So let's say we go to the Australia, for example, they may have the peak sun hour or the PHH greater than us. For example, let's say 5 or 6, for example. So that it represent that availability sun during the 1000 watt meter square for that particular location is greater than us, which is they have more available sun ray. I mean, representing the Australia climate condition. Okay, guys? Is that okay? For that question number 14. Chow, okay Chow. Kalau Chow tak
Okay,
okay,
sir.
tak okay lah.
Okay.
Okay, okay. So I think the keyword is that 1000 watt meter square tu Chow. It represents how many hours we can have that kind of 1000 watt meter square. For example, as your answer, so we managed to get the 4.5 hours for the 1000 watt meter square. But need to remember, guys, of course, we cannot get the consistently 4 hours directly, right? So, of course, during the time, it will be fluctuated, but then we can try to average it, and yet we get the 4.5 hours daily basis, as Chow mentioned, from 11 to 3 p.m. or something. So that's the the peak sun hour for Malaysia. Okay, for others country, it may be give us the others value of peak sun hour, but it represent the availability of the sun ray during the 1000 watt per meter square for how many hours for the day duration of the daytime. Okay, okay, Chow, boleh ya?
Okay, sir.
Alright, thank you, Chow. Okay, next, last group lah ya, kan? Last group lah, sebab kita ada 15 group aja. So, 15 group, so tengok dulu siapa member dalam group 15. Okay, alright. Saya rasa sudah tahu dah siapa nak jawab ni. Okay, kita ada Emmanuel Pang, kita ada Syabil, kita ada Nur Haja, kita ada Owen. Okay. Owen, tengok ke bola tadi Owen? Lawan Iran. Okay. So, anyone from group 15? Anyone? Anyone from group 15? Any representative?
Hello, dengar tak? Hello, sir.
Oh, okay. Nur Haja. Nur Haja juga kena jawab ya. Okay. Kuat sikit, Haja.
Okay.
Kita tak sihat juga ke? Batuk-batuk juga biasa.
Saya demam.
Betul lah. Kenapa? Post-COVID ke apa?
Tak, dah check dah bukan negatif.
Demam biasa lah. Demam biasa.
Demam biasa.
Yalah. Ke macam kuat sangat ni, kempen ni?
Tak.
Okay. Alright. Alright, back to the question, Haja.
Okay.
So, group 15, what is the difference between irradiance and the radiation?
Okay.
Yeah.
The difference between irradiance and radiation is irradiance is the amount of energy received from the sun per unit area of the collector.
Okay.
While for radiation is the energy emitted by the sun itself.
Okay. In terms of the unit, sama tak?
In terms of the unit, for the radiation, irradiance is W watt per meter squared.
Okay.
For radiation is watt per meter squared steradian.
Apa? Yang second tu.
Yang radiation tu watt per meter squared steradian. STERADIAN.
Steradian.
Steradian.
Oh, okay.
Okay.
So, others want to add on, or others group member want to add on, or others want to ask. Okay. Habis lah WhatsApp korang baca semua tak apa lah, tak ada apa pun. Kerja-kerjanya WhatsApp. Okay, right. Okay, so thank you, Aja, for your response representing the group. Aja ketua kan? Ketua.
Ya, Doktor. Hajar ketua.
Ya, Aju je. Mana faham pun. Okay, biasalah tu ya. Okay, kita tak apa. Alright, okay, I think the direct definition, I think you may try to get in the lecture note or in the other sort of references. So just want to give you in a form of the different unit wise lah, kan better macam tu kan, you guys then macam tu lagi mudah you guys nak ingat ataupun faham ataupun have the clearer picture to differentiate between each other. For the irradiance, the unit is the watt per meter square. Okay, so that one is everybody agree lah kan, now we are using the irradiance watt per meter square. For the radiation, the unit is the watt hour per meter square. So when we deal with the hour or H or hour or time, so it refer to the consumption of that particular radiation. Okay. So I think that's the two obvious difference, how to differentiate between the irradiance and the radiation. Beside the detailed definition of each lah. Kan, macam yang Hajar cakap tadi kan, kan the definition tu, okay, fine. Tapi to make it very clear, we can see also in the form of the unit, which is for the irradiance, watt per meter square, and then for the radiation, watt hour per meter square. Okay, guys? Okay. Okay. Right. Okay, Ajar dah buat thumbs up. Aku pun dah buat thumbs up. Okay lah tu. So now is 11:14. So I think we still have a time to proceed the two bonus question. Okay. Which is we start with the why the monocrystalline high efficiency compare the polycrystalline. So ini ada siapa nak try to respond tak? Ke yang ini answer juga ni? Okay, number 16. Why monocrystalline produce the higher efficiency of the compared to the polycrystalline? I mean, in the form of the PV, right? So monocrystalline is the material that produce the solar cell. Same goes to the polycrystalline. Okay, but why monocrystalline offer higher efficiency compared to the polycrystalline? Anyone want to try? Just stop sharing this one first. Anyone want to try? Sebab dia bonus ni macam tak wajib jawab kan? Anyone want to try? Kita dah habis masa Sorry. Kan dah habis kan, guys?
Dah habis dah tadi.
Okay, sorry. Seronok sangat buat Q&A. So kita hold dulu. Sorry. Kita hold dulu that part. I mean that bonus tu. Fortunately, in the part of the bonus lah kan. So guys, we will share this recorded version later. So thank you very much. Sorry taking your time. So take care of yourself. See you around on this coming Thursday. With that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh and have a good day everybody. Sorry.
Thank you, Doctor.
Thank you, Doctor.
Thank you, sir.
Seronok sangat ajar
Thank you,
tutorial.
sir.
Seronok sangat ajar tutorial.
It's okay. Thank you, sir.
Okay. Thank you very much. Okay, welcome. Thank you. Okay.
Thank you, sir.
Okay, welcome. Muka mendapat sihat kan? Okay. Alright.
Saya Doktor. Assalamualaikum.
Sama. Assalamualaikum warahmatullahi.
Ajar kita.
Okay, sama. Okay. Cakap sorry dekat lecturer sebelah ni. Siapa lepas ni? Apa? Korang? Dr. Soela Ke tak ada kelas sebenarnya?